Can you please confirm if my screen is visible?
Yes, it's visible.
Okay. Yeah. Okay. Um yeah. So just wanted to introduce my profile. This is my profile and the company's profile. So we are into trainings and research innovations, and it is an R&D company. We are into trainings and product development and research and development into 4G and 5G, and going forward 6G also. So this is some of the talks that previously what we have achieved from the company perspective, given to corporate trainings, and also some of the like IITs I have given, and some working professionals as well. Few guys are already into Nokia and different kind of companies. Uh, Sorry, just a second. Okay. Sorry for the delay. Yeah. Okay. So this is my profile. Basic, just an introduction about this. So I work for different companies, engaged with different product companies as well, and um, the interest is into SDR setups and all. So basically, we do the lab setups, 4G and 5G wireless, and for the 6G experiments also, we are into the simulation setup. So this is a basic background. And coming to the today's agenda, the MAC functions and also channel mappings and MAC PDUs and SDUs, a bit of MAC demos also that we can see. Sorry. Okay. So coming to the MAC function. So before going to the MAC, I would like to just give a brief introduction about the basic technology. I don't take much time into this part. Um, so we have three domains when it comes to wireless. I hope this is visible. Can you please confirm?
Visible, sir?
Yes, yes. Yeah, thank you, thank you. So, and this is eNode B or whatever you call it. Basically, I call it as access domain, and this is a core domain. So, this is the end-to-end picture where we wanted to do some L3 call. L3 call, I mean, we wanted to do some phone call or a data call, whatever it may be. Idea here is end-to-end. We wanted to get the network. That is the main idea here. So, if you are looking at UV space and the base station space and the core space, so there is something called as protocol stack, but there are multiple things are there. One is hardware, another one is on top of the hardware we have something called as device drivers. On top of the device drivers, like these are all actually a part of operating system. When it comes to the development, you can say it is like Linux for the development of all these protocol stacks. There is something called as protocol stack. So we will touch upon that part basics in detail. But on top of the Linux, we are going to develop the protocol stack. But this scenario present for all the nodes or all the network elements like UV side or the base station side or the core side, or in fact wherever it is actually connecting to, like IP network or IMS network for the VoLTE calls, right? So these are all the things necessary. Actually this protocol stack is necessary, but it has to support, I mean the hardware has to support for execution of the data whatever is coming from the application side. For example, you are doing a YouTube or Facebook or WhatsApp, so these are all applications, but how can I get into over the air interface? That is the main point here. Okay, this is air interface. So for that it has to go through the protocol stack, but in fact we have something called as control plane and user plane protocol stacks. So I would like to give a basic example about this control plane and user plane, I mean just to have an analogy and visualization to understand. So there is a song, okay, music, one song is ongoing. So if you want to prepare one song, okay, we'll divide this into two parts. One is like soundtrack and another is like data. It means like voice, whoever singing that particular whatever. So I can say this is called as payload or the actual data. Okay, and this soundtrack I call it as a signaling or it is a preparation. So this is one example. And if you look at another example, okay, two people are actually making a conversation over the air medium. It means before making a conversation, okay, air is already prepared to send from this side data to this side and this side data to this side. It means here I call it air as some controlling medium, okay, which is responsible for sending the actual data. So that is the main thing. So now coming back to this control plane and user plane, means who is actually responsible in our case, wireless, whether it is UV or eNode B or core, or what is the actual data. Just a moment, sorry. Okay, so coming to this control plane and the user plane, when it comes to control plane or the user plane, we have the protocol stack which is fully responsible, but below that I agree that all the hardware and the device drivers and the Linux, all these things are responsible actually. But for driving the wireless or the 4G or the 5G stack, the control plane and user plane protocol stacks are actually responsible. It means at the UV side we should have control plane and the user plane stack, and the base station side we should have the control plane and the user plane stack, and for the core side also. But now the current context, I'll just set the context now, okay, with this background. So the context is like what kind of protocol stack layers that we are observing, or we will see, so that they are actually responsible for taking the YouTube data or WhatsApp data, whatever you can think of, okay. So that protocols that we are actually going to have a look in this course journey actually. So I'll just write it some protocols, okay, like RRC, RLC, MAC and PDCP and 5 layer. So these 4 protocols, okay, apart from this, basically this comes under control plane protocol, which you can think as a soundtrack in the previous example what we thought, okay. And this is these 2 protocols, or these 3 protocols, we call it as L2, and 5 layer we predominantly call it as L1 protocol. So this is actually responsible for sending the packets, YouTube packets or WhatsApp packets, okay, that will be sending over the air. So in case of LTE, we have air interface, which is UU, is the air interface actually, okay. Now how to drive this one? It means whether RLC is responsible or MAC is responsible or PDCP is responsible or RRC is responsible. Who is actually responsible for sending all these packets over the air? But if you observe this one we actually call it as user plane data, means actual payload, right? So this one also has to go and this one also has to go. So for this, how these layers are actually interacting, but here if you see RLC and then MAC and 5 layer, in fact, okay. So I'll just erase this is not the one. So how the stack actually looks like, here PDCP and it is RRC. So the moment I talk about RRC, basically here this entire stack is responsible for control plane. So this is only at the UV side. Now coming to the base station side, how it actually looks like, exactly the same thing, base station side, but base station has higher responsibility, because in one particular coverage, it can be handling multiple cells also, right? If I say base station is somewhere here, now it has to handle so many things, it like RRM and then OAM, right? And OAM has multiple things, software management and configuration management, fault management. So these are all different managing activities apart from this stack maintenance. So here the context is like, I'll just talk about the RRC and PDCP because the communication has to happen. So because we are actually discussing about just one UV, then RLC and MAC and 5. Okay. So today's topic, I'll discuss about this part, one of the layer, which is MAC. I hope this is clear until now. And here core network. So core network has multiple network elements. We have MME, S gateway, and then P gateway. So these are all the different network elements who are responsible for control plane and user plane. User plane means it has the protocol stacks also for this. Okay. Now coming to this one, I would say if it is a user plane stack, we have only IP layer, application layer. Now here the PDCP packets will come. I'm talking at UV side, and RLC and MAC and file layer. So these are the layers which you can observe whenever a packet is ongoing, which is a data packet or anything, Skype server or whatever you can think of. So this is the way how we have to look with respect to the user plane inside UV. But the point here is how this interaction will happen. That is the entire course journey for this. Okay, but I would like to highlight of the based on the today's topic now. So in this, what we are actually trying to learn here is how these layers are actually interacting. That is the main thing you have to understand. It means there is something called as channel mapping. Why there is a channel? And the meaning of channel is completely different when it comes to the different layers when we are understanding. So as we know, when we are sending some data, we are sending something in uplink. When we are receiving the data, when we are receiving something in downlink. Now UV and E node B. So this is the main context now. Okay, we'll discuss about this part for today's discussion. Sorry. So uplink means we have different channels that we need to understand. Now majorly the layer mapping is like RLC, MAC and physical layer. So what kind of channels? So we have logical channels, transport channels and physical channels. So when it comes to the logical channels, we have CCCH, DCCH, okay, and yeah, depends actually whether it is uplink or downlink. Okay, so there are multiple things. Okay, let me just give that whole picture now. Yeah, so I hope this is visible. Now when it comes to the channels, so this is basically downlink channel mapping. It means whenever base station wants to send something in the downlink, now E node B is actually trying to send something in downlink. When it is sending in downlink, for the control plane or the user plane responsible messages, okay, that can be coming in this particular direction. But what kind of messages will come? This all depending on the type of the message what UV is trying to expect from the base station, right? For example, paging in the sense you have some alert message, and broadcast, it means like the initial information which are necessary for the UV in that particular coverage for the UV to connect to the network. It means it has to attempt something called as RACH procedure, and it has to get RRC connected, and later dedicated resources that base station has to send, right, with the help of these messages. And then finally, once it is getting connected through the attach call flow, there is something called as attach call flow. So I'm not going to talk about that part because it is a big call flow and procedure. Okay, now after the attach, it means assuming that attach is done. Attach is done in the sense a minimum data rate that UV can get. That is number 1 point. On the number 2 point is for the responsible, the reason for getting the data is the allocation of the IP address. But who will allocate the IP address? It is P gateway. Sorry. So P gateway will allocate the IP address. That is the main thing. P gateway, and we have S gateway also, right? The direction it will travel towards the E node B, and finally it will go to UV side. So in this particular slide, what I'm going to discuss is only about this part. Okay. So the downlink direction, if you have a look, so this is the logical channels, and this is the transport channel, and this is the physical channel. So whoever are, I mean, whatever the channels are there, which are logical channels, that will be handled at the RLC layer. But it has multiple modes actually, TM mode and AM mode. Okay, so I don't want to talk about much about that part. But here, if you have a look at this PCH, BCH, and DLSH. So these are all only downlink transport channels who are responsible for carrying the data, like paging or MIB and SIP, right? So through this, the data can be sent, and through the which physical channel we are sending. So every channel has one particular purpose and the direction of travel through which logical or transport channel it has to travel, so that it can reach at that particular layer. So if you think, okay, here this is handled at RLC layer and this is handled at physical layer. Okay, so there are so many things to understand here. At the PDC stage, we have something called as DCI, we have something called as CRNTI. Okay, so multiple things are there. And at the DCI, we have again like aggregation levels. Okay, at what level in a particular coverage, when the UV is experiencing the bad signaling conditions, what kind of aggregation levels that the base station has to plan for a particular UV, right? All those things will come into the picture when it comes to the PDC stage. So because today's discussion is about the MAC, I don't want to go much in detail about that part. Okay, let's concentrate on MAC. Now, so with this, okay, so this is the downlink channel mapping, and accordingly we have uplink also. Okay, so uplink is something medium how we are actually sending. This is a general statement. This is a generic statement, but the point here is it depends on the context where you in which situation, in which context you are actually talking about. The moment you talk about the protocol stack, okay, the moment you talk about the protocol stack, I would say channel is something like it is a passing something through which one you are passing. RLC you are passing through which one you are passing. So this is what I am actually naming it as logical channel. It is a medium from RLC to MAC, how it will go, right? There is something should be there. So this, I mean, in the development aspect, you will come to know very clearly all these things. Okay, but just to a conceptual view, logically to understand. So I am just mentioning here. Now the MAC is actually sending to physical layer. Physical layer in the sense you are actually sending to the physical layer the entire channel processing. Processing in the sense physical layer is responsible. Physical layer is a software, you can assume. I am not talking about hardware also even. Okay. So on top of the hardware, until going to the hardware, it means like the direct antenna port I am talking about. Okay. So with this, let's say this is a PUSH processing. Okay. Now you are actually sending UTIP packet and it is a user plane. Now you got until the PUSH, right from the MAC, right from the RLC, everything. IP layer, all the things, PDCP, RLC, everything. Now you got here. Now this is 1 TB you have to process now. Okay. Now when it comes to the 1 TB processing, because this is uplink, right, it will go through the PUSH channel. Okay, channel in the sense medium, but your ultimate goal is to send towards the air. Now how you will send it to the air? You have a steps actually here, encoding, rate matching, and then CRC, okay, and scrambling, and then layer mapping, modulation, FFT operations, so many things, and pre-coding, whether you are using single MIMO, single user, single MIMO or multi MIMO, right? It all depends actually. I mean, what this channel is demanding, accordingly your layer channel processing, layer specific processing will be done before it is actually sending over the air. So in this situation, this entire thing I call it as channel processing, but not channel. This is the medium you are actually considering in this particular situation, that you are actually sending over the air. I hope I answered your question.
Yeah, got it. But this PUSH, it could be a process from RLC. We can send the data to this PUSH process. From there, it will go to the physical or other layer. I think that could be the answer, right?
Correct. Correct. See, there are so many different situations. I'm just giving one example.
Yeah, I just wanted to know what exactly the channel, whether it is a IP address or port number, whether we are sending
See,
it to
IP
that port.
address and port number, the moment you're talking about IP address and port number, we are actually talking about the end-to-end IP connection.
Okay.
That is, you can treat it as a channel, but that is an end-to-end channel.
Okay.
But here, the moment we are talking about this one, we are actually talking about exclusively related to air interface. It means between UV and the base station, that's all. But still, UV and the base station, we have air medium, that also we can consider it as a channel. And across the layers, when we are thinking about this logical and transport and physical layer, these things also we can treat it as a channel, but still it is internal to the system, it is not external.
Okay, got it.
Understood, right?
Yeah, got it.
Okay, yeah. So this is fundamental about the basics about the Mac. Now let's, I'll just touch upon few of the things. Yeah. So, yeah, we were here actually. This one. UV side and the base station side. Okay. Now, I wanted to send something which is PUSH in the uplink. Let's say it is YouTube data and it came until the physical layer. Now I have to send through the channel processing over the air. Now for the base station it is RX, which is PUSH, but for the UV it is TX. Still it is PUSH. You have to receive, that's all, right? But until and unless base station is scheduling in that particular frame. Okay, so again this is a physical layer discussion. I don't want to distract actually, but in the frame structure there is something called as frame structure where all this PUSH, PDCH, everything will fit in. Okay, but the base station prior in advance has to schedule that particular thing, like frequency, time and power, and what is the modulation scheme, what is the channel condition, accordingly what is the RBs, resource block, everything that it has to consider and do an optimistic scheduling according to the cell load and according to the quality of service. Okay, so all these things will come into the picture. So idea here is when we are sending this data in the PUSH, okay, but still you don't have the resources, for example, means base station is not scheduling, but still you have some data in the buffer. In this particular situation, any of these three BSRs will be sent. BSR means buffer status reporting. Okay, it means like, boss, I have some data. Okay, I wanted to send something. Please schedule me and give the resources. I have something to send something in the uplink. Please grant me the permission and allocate me the resources. I have some data. I have to send it to the uplink. So that is the main intention why these three control elements are there. And one more thing, this is another MAC control element, which is like power headroom report. It means you have to control some power because spectrum is always scarcity, right? We have to use in a very much efficient manner. That is one thing. Means you are expecting the UV to send the power report time to time so that I can allocate exactly how many you need. I don't want to allocate more resource blocks or less resource block. I wanted to allocate exactly what you are expecting. But I will take and I can understand that, okay, you have sent the power headroom report, then accordingly I am allocating only this much resource blocks, means this much frequency, time and power. So time talks about scheduling, okay, F talks about the carriers, this one talks about the power, at what power you are actually sending and with what modulation scheme, modulation and coding scheme. So this will drive the entire data towards the air. I hope you got some clarity about this one, what is the actual data and how it is actually sending. Anybody have any questions until now?
Hello.
Yes.
Like when we are talking about Mac, so you are saying that physical is different. So can we learn like as independent units, as physical layers are different? So skipping physical, can we still go to Mac layer? Like,
okay.
Understood.
Are
you getting my point?
I understood your question.
Okay, so like can we understand like independently we can understand, or we have to go through step because they are linked, because when you are saying that when we transfer them from air, So we have to go through like pre-coding, what is the encoding, like the OFDMA part, such thing, and the channel estimation, like the resource blocks and all this metrics
Understood.
in physical layer.
Hmm.
So can we like these things can be learned independently also, or like how?
Okay.
Or first we have to go
I would
through,
say one
or
thing.
we have,
I would say one thing. Okay. So depending on what is your end goal. Okay. End goal in the sense like, see, you are concentrating only on Mac. Fine, you can concentrate. If you are concentrating only on fine, you can concentrate. Okay. But RLC and PDCP, the moment you are talking about RLC and PDCP, these are all combined things. L2. Okay. This is L1 and L3 is RRC. Okay, so if you want to concentrate only on Mac, first of all, without the logical channel, transport channel, physical channel, in a given particular situation, for example, you are receiving some paging message, right? You are receiving something towards the Mac, but how you will receive, when you will receive, through which logical channel you will receive, and who is actually sending, whether that indication is correct or not, right? Means without the understanding of these things, it is very difficult. Now, if this is one approach. Now the other one, you understood all the layers, but not in, I am not talking about practicals, I am talking about the fundamental specification understanding. Okay, so PDCP, RLC and MAC and PHY means you know about the logical channel and transport channel and physical channels, uplink, downlink, control plane, user plane, what is the purpose, right? For every channel, for every given scenario, you should know this one in and out. Then you are fine to work independently on any layer, because the requirements will be sometimes you may be working in some physical layer, though you are a Mac guy, example. Okay, so if that is the case, without this entire thing, or at least at the Mac and PHY, because Mac and PHY are always combined. If you want to do a processing at the physical layer, first Mac has to send something through which layer it will do the processing, right? So all these things that should be kept in mind for analyzing at least.
Okay. So like when we discuss Mac, then we will cover like the physical also and the logical also.
Okay, I will tell you my way of approach actually to have an end-to-end look, and at the same time with respect to the air interface aspects. Okay, so generally what I will do, even in the previous discussions also I have already done with the previous my students. Okay, so it is something like, first of all we have to understand end-to-end. UV, base station, it can be anything. You can think G-Node B also. I am just giving an example. Okay, EPC. Okay, EPC. Now here, of course, NAS layer will come into the picture. NAS layer will come into the picture, and we will have something called as attached call flow, or the so-called, we call it as L3 call. Okay, so this one we will understand first. But it doesn't mean that we are going completely into detail, because that is altogether again a different aspect, different course altogether. Okay, now with this background, with this context, control plane and user plane. Okay, I'll show you the curriculum what I'm actually covering. Control plane and user plane, and the stacks involved everywhere across the end to end, and we'll start concentrating on this. Now UV and the base station, we have control plane and user plane, control plane and user plane, downlink, uplink, everything is there. Now with this background, we will start understanding. There are two parallel understanding should happen now. Okay, after this background, So what is that background, what is that parallel things, that now let's discuss about that part. Okay, so idea here is, with the NAS call flow in place, with the architecture, with the protocols, with the basic protocols, and with the uplink and with the downlink and with the control plane and the user plane. These are all the backgrounds. First I will set the context. Now what next? So the next thing is like, it will got two things. One is like sequence. Number one, sequence in the sense, the moment UV switch on, what will happen? Whether the physical layer is up and running, whether the NAS is up and running, whether RRC is up and running, what is actually happening inside? And UV is tuning to which frequency, what is the capacity, what is the SIM card settings, right? And it should identify the PCIs, it should go through all the cell search and frequency search. This process it has to go through, and MIB and SIP decoding. It means, what I am trying to say is like, this sequence should be there in mind, but in parallel to that, the layers, file layer. So predominantly what I will do is, first I will cover the NAS and this end-to-end flow, then I will start with these two things, because you should understand the layer aspects and also at the same time the sequence. So in the order, I will cover NAS, after the architecture and protocols and control plane and user plane. Number 1, number 2 is NAS, number 3 is like, first I will start with the physical layer, then I will go with the RRC, because you have to understand the configurations. So in the RRC, we will understand all these MIB, SIBs, other things like reconfiguration and connection, establishment, re-establishments, everything that you will understand. Now, what is the next step? Next step is MAC. Because though the physical layer is like the ultimate fundamentals actually, the air interface aspect we are actually talking about, that is the physical layer. Now with the configurations in place, then you are in a better position to understand the MAC, to understand the RLC, to understand the PDCP. With this, you will be in a position to understand. I mean, you would have already reached the stage of control plane and user plane in and out. Now with this background, you will try to understand the user plane. But user plane is, when compared to control plane, okay, user plane is all about the packet analysis and drops. See, the moment you observe any call drops or any of the aspects like signaling conditions are bad, so those things are actually purely control plane aspects. Here, the moment you talk about the user plane aspects, we are always behind this UDP and IP and packets, right, and throughput aspects, capacity, right. These things we will talk about as a part of user plane. This is the entire sequence of understanding. But what is the end goal here? So you understood all the things. Now concentrating on MAC. Now this is the actual step. If you are concentrating on MAC, but how to think now? Because MAC should have so many different functions. Okay, let me just open that one. Function. Please try to have a look at just a basic thing. I don't want to go much detail. Here, number 1, mapping of logical and transport channel, MAC's job. Multiplexing of the SDU, which is sent to the physical layer. Because now we are deep inside the MAC with the background that we have already set everything. Now inside the MAC, how to understand with respect to the other channels, but when we are actually sending, in which situation, whether it is paging message, whether it is RRC connection message or attach messages, you wanted to drive across the RRC because you have to send something to the NAS layer, right? All these things will come into the picture, but basically it is divided into two parts actually, when we are talking to the core network and when we are across the air interface. Okay, you have to bifurcate and do the two things to understand better. But how to bifurcate? And what actually 3GPP specification is talking about? So that one is basically like NAS protocols and AS protocols. AS means access stratum and NAS means non-access stratum. Okay, so access stratum is like, just now we have discussed RLC, RRC also, PDCP and MAC, and down we have air interface, and this is 5, right? Okay, so this is division actually. So if you are working in access, so by the way, actually there is a little difference in the way of interpretation by the tester and the developer. This is very, very important actually, because a developer is always only in one layer. He never care about that end to end. It is there, but just some basic idea. But still we should be able to answer, right? So tester will always look end to end. Unfortunately, they don't know that these in-depth details until and unless you have gone through a very good detailed specification understanding, deep understanding. Okay, so those things that we will be covering as a part of course, all the layers actually. Okay, so the moment you are talking about MAC, okay, you need to think about these things: how to send it to RRC, how to send it to RLC, or how to receive from the RLC. If you are receiving from the RLC, it is TX. If you are receiving something from the physical layer, it is RX. It means the moment you are thinking about MAC, you have two things to consider here. One is TX, another is RX. The moment you are thinking about TX, you are expecting something from RLC. The moment you are receiving something towards the MAC, so this will produce the PDU, which is equivalent to MAC SDU. Now the job is like, you have to put all the SDUs into one place and form one particular PDU, which will become 1 TB, which is transport block, and this is the input for the physical layer. But the sequence here, what we understood, this is basically TX sequence. It's not RX. Now RX. So let's try to understand about the RX part here. RX in the sense you are expecting something from the physical layer. Again, the reverse direction that you have to think now. It means you got something from physical layer. Let's say this is PDSH or PDCCH, whatever it may be. Okay. But you are receiving something PDSH, maybe some packets or something, paging message or anything you can think of. Now it has to reach to the RRC, because RRC paging, for example. Okay, now here PDSH, you have received 1 TB of the of 5 data, which is in the form of bytes. But physical layer never understand whether it is paging or whatever, 1 PDU or nothing. It understands only one thing, some bytes of data, which I am actually, my language is one transport block. And MAC never understand what is the meaning of TB. MAC's language itself is PDU. Now while receiving, you are sending some TB. I don't know what you are actually sending, but I am receiving one PDU. Now my job is I have to process, because this is RX, I have to take it to the RX HARC, which is DLSH HARC this time, because it is downlink. Now you process through the HARC and then send. Where you are actually sending? You are actually keeping, because this is paging message, right? So what is the channel mapping now? PCCH, PCH, and it is PDSH. This is the paging. Now RLC here, RRC here. Now my MAC is here. Sorry, this is DLSH. Okay. I'll assume some different message. Sorry for that. Just to have a clear understanding. So PDSH, DLSH, let's say DCCH or DTCH. So DTCH is YouTube packet and DCCH is, for example, authentication authentication request. Okay, this is a NAS message. Now here you are actually receiving PDSH and DLSH. So DLSH ARC has to process. This is expected by the specification 38321 or 36321 if it is a LTE. Okay, if it is 5G, it is 38321. If it is LTE, it is 36321. So what has been written in the specification? Okay, this rules has been written in the 36321. Now the MAC has to understand how to process. That is internal mechanism. That is the design. That is the development. That is the coding. That is the implementation. That MAC has to think how to send, how to efficiently manage the resources to send towards the RLC layer. Now you are actually sending SDU. You are actually sending, and you are doing demultiplexing. This is one of the functionality. Now you can see here. Multiplexing. Multiplexing means you are sending something in uplink. I mean you are sending TX actually. Okay, and demultiplexing means you are actually receiving. But this is equally applicable at both UV side and the base station side. The functionality is exactly same, but only few of the features are in uplink and few of the features are in downlink. For example, here UV side, base station side, downlink or uplink, whatever marked in X, those are all applicable for that particular network element. It means like UV or the base station, and what are the functionalities that are actually applicable. Demultiplexing, for example, this is applicable for UV also, UV in the base station, right, and base station UV in the downlink, and for the base station also it is in the uplink. So these are all different functions actually. Transport format selection, priority of the priority handling of the UVs, priority handling of the logical channels, logical channel prioritization. This is only UV and the only uplink. You can see here. So this is one of the very core feature, okay, which will drive the entire bitrate also, and scheduling information reporting. Okay, I hope this one is a little clear. Have any questions? Oh, sorry. Is my screen still visible? Hello?
Not now.
Oh, now it's not visible. Sorry.
Well,
Just a second.
yes, I stopped.
Okay, fine. I think now it's visible. Or okay, let me just give some demo related to the Mac. Okay, I'll just take another screen because it is little difficult to show here the demo. Can you please confirm if this screen is visible? No, some issues there. Just give me 1 minute. I'll just logging into the system, Linux system. Some issues there. Okay, I think some issues there. Let me just talk about the curriculum, what I'm actually trying to cover here. Yeah. So, can you please confirm if this is visible? Hello.
Yeah, it's visible.
Okay. Sorry, actually, I was about to discuss about the demo. That is some issues there with the system. So let me just talk about the curriculum, what I am actually covering here. So this is 5G aspects, 5G and 4G as well, but I'll talk about the entire curriculum, what I am actually covering. Um, So when it comes to the air interface protocol, we have all the things what we have discussed. One is like physical layer and the MAC layer, but I'll start off with the basic fundamentals also. Just very quickly I can go through. You can see here. So as I said, this LTE NAS introduction. Basically, we have something called as bearers. Okay, quality of service and the bearers. Guaranteed bitrate and non-guaranteed bitrate, and LTE actually starts with release 8 and around release 10 also, and still covering as a part of this, but there are multiple releases, or there release 13, release 14. Until release 14 the LTE will come into the picture. Now coming to the NAS, as I said, this is a basic attached call flow, but few of the things most essential to understand the end-to-end call flow that I will cover. Like attach and detach and combined attach. We'll go through the Wireshark logs also, necessarily whatever is needed to understand for the basic air interface call flow. That also we will cover some of the aspects that we will cover. But coming to the physical layer, this we will go in very much deep, because this is the air interface. So we have the specification numbers, which is 36, 211, 212, 213 and 214. These are all the LTE specific specifications by the 3GPP. So physical layer specifications are these numbers, but still the same numbers are valid for the 5G also, 3G also. But the only thing is this number will change. When it comes to the 5G, it is actually 38 series. If it is LTE, it is 36 series. So in the physical layer, in the LTE aspects, we will cover spectrum and RFC and DL, uplink and downlink, frame structure, OFDM, downlink and uplink frame structure, FDD and TDD, and some of the TTIs and the frames and subframes, how the structure and what all the different channels are there, that we will cover, PDSH, PDCH. So I was discussing about this part, some of the aspects here. So these things we will cover. And signals, so there is a difference between channel, signal and message. These three are completely different altogether. Okay, so we will dig deeper actually, what is the message, why they are different. Okay, what kind of different things are there in the physical layer aspects, and along with the other RRC aspects also. So uplink, we have POSH and PUCH and PRACH and signals again here. And for the TDD, we have special kind of configurations. Okay, downlink PTS and subframe configurations. Because of the reason this is supporting within the single frequency, the configurations will be done. Okay, unlike FDD, we have separate frequencies for both uplink and downlink, but in case of TDD, within the same frequency, same bandwidth, that we have to plan the TDD configurations. So that's why the bandwidth will be limited in the TDD. That's why the different kinds of techniques and mechanisms that we will learn in the TDD aspects. And coming to the MIMO, there is something called as transmission modes. So this one talks about the layers and the diversity techniques. There is something called as diversity techniques and multiple things like beam forming and also layer mapping, right? Multiple things that will pre-coding also. Okay, all the things that we will cover as a part of physical layer. And there is something called as DCA formats, which are crucial, and this is mainly talks about the scheduling aspects and where the allocations are there. UV time to time it will try to identify the locations. Where is my PDSH? Where is my PUSH? So that I can send the data or I can receive the data, right? So all those things that will be actually part of scheduling aspects that we will cover in the combination of physical layer and the MAC layer. And channels, logical channel, transport channel, and the physical channel, and channel coding, channel processing basically. So I was just mentioning coding, scrambling, layer mapping. So these things that we'll go through. Basically this is sometimes MATLAB is necessary to understand, but I'll talk about in brief, because implementation perspective it will be very difficult to understand those things. Those are all like software layer processing, and at the same time we are actually matching to the MATLAB simulations. But those things are possible with the help of hardware also, but still as a part of the project, okay, we will try to understand some parts from the MAC layer perspective. And also physical layer aspects also we will see PDSH decoding and the PDSH decoding and encoding by the base station and decoding by the UV side. So this is all about the physical layer aspects. But coming to the throughput and other aspects like signal is bad, or the coverages are not good, bad signaling conditions, right? And accordingly the adaptations and all these things that we will cover as a part of this one. Okay, so random access also will cover, but random access I'll cover in MAC majorly, but it is a combination. The moment we talk about the random access, it is a combination of three layers in fact. One is physical layer, one is RRC layer, and another is MAC layer. So the moment we talk about the radio resource controller, which is RLC, okay, this is basically, I mean, in the context of random access. So we are majorly we are actually talking about the configurations, MAC configurations, physical layer configurations that are actually necessary for the UV to do the random access. So those things that we will cover as a part of the RRC part. Then in the physical layer also, how the preamble signature will be sent, right? So those things that will be covered in the physical layer. So coming to the RRC aspects, I just mentioned how the sequence will start. So as a part of RRC, slowly it will come actually, because initially it would have already started in the physical layer, because that cell search, frequency search, and scanning and identifying the physical cell ID, right? So those things will happen, means as a part of physical layer only some part I will cover. So slowly, time to time, what will happen is parallelly you will be understanding the layer also. At the same time, we are not losing the information that we are actually going to cover the sequence also. So this sequence and the layer understanding should go hand in hand and in parallel. Then we will be in a position to understand at the end of the 2 months or 2.5 months, you will be in a very, very good state that you can understand better with respect to MAC layer, with respect to RLC layer, with respect to physical layer aspects. Okay, so that sequence we should not miss. That is the main thing. The main important thing is, if you are missing one class, it will be very difficult to understand the next aspects also, because the context will be completely different and the sequentially following will be little difficult if we are missing some one or two discussions. Okay, but we'll try to stick to the discussion as maximum as possible. So coming to the sequence, so this is actually sequence, DL synchronization, SIB, and then PLMN selection and cell selection, reselection, and this is when it is in idle mode, and when it is in connected mode also paging can happen. Okay, we have two types of states where UV can able to spend. UV will be in one of the states, idle mode and connected mode. So when it is in idle mode, it can able to receive all this information, and when it is in connected mode, it is eligible to send some things and it can able to talk. So I was talking about the channel mapping. So RRC has a different types of messages, ULCCH, DLCCH, right? All these things that will be covered, RRC messages. So I was talking about messages, signal and channel. So three are actually different. So the moment we are talking about the messages, this is one of the example, RRC message. So like that we have NAS messages also, S1AP messages also, like that multiple messages are there. But in the RRC context, these are all the messages that you need to think. So connection control means these are the procedures. So whenever you are understanding any layer, we have to think about messages, we have to think about the formats, and we have to think about the procedures, functions, services, how those things are actually specified in the specifications. But when it comes to the development with the C++ or C or Linux coding, how I can implement, what is the framework involved, how at the ground levels I have to understand. So those things and all, okay, that is the actual thing when it comes to the development. But those things I will cover, what kind of implementation aspects that we need to understand along with the domain aspects. So that I will discuss about that part in some time after completion of these layers. So measurement configurations. So I think in case of handovers, we have different kinds of measurements, whether measure I mean this will reduce the signaling overhead a lot actually, because of the reason when the UV is actually reporting something at the base station side, okay, it will take the decision what are all the signaling conditions, what kind of radio access technologies that the UV is actually sending the measurement reports. It means like the signaling conditions of the individual cells, what UV can able to detect. That is number one. Number two is like base station is trying to configure the UV to do the measurements and report me back, so that I can take the handover decision and I will reduce the signaling overhead. So that is the main intent what base station is trying to do this operation. Measurement means measurement configurations with respect to all these events that it will configure. So there are multiple techniques and mechanisms are there to reduce the signaling overhead. And handovers. So different kinds of handovers are there. Different flavors actually. This is between one base station to another base station. This is in two situations. One is if the x2 fails, that is one case, and another one is there is no contact between one base station to another base station. Means through MME or through core network we have to go for the handover to happen. That is one flavor. Another one is inter-rat, means when we are going from 2G coverage to 3G coverage or 4G coverage to 2G coverage, like that, the multiple combinations. But here like we will cover only these three things, okay, because CDMA's technology is very rare, people are actually going into that, okay. So these are all the different procedures basically, okay, and other things also we will cover, procedures involved, and medium access control. So here it is L2 actually. So here just now we have discussed the functions, right? But along with that we have channel mapping and other services. So when it comes to the L2, we have some kind of commonalities that you need to understand. There is something called as architecture, services, functions, procedures, right? This is common across all the L2 layers in fact, but the internal implementation and the specification changes according to the context, according to how the layer should be, okay. And we have PDUs, MAC control elements, okay. And when it comes to the RLC controller, we have TM, UM and AM. So here also you can see functions, architecture, services, procedures, right? So this is the main medium towards the air interface. It is actually able to control all the packets both in TX and RX. So whatever the data, the payload, whatever we are expecting, that will be majorly handled by the RLC from the L2 perspective. But PDCP is there for the transmission of the data along with the encryption or security aspects also that PDCP is able to handle. So that's what actually you can see here, protection and the format. So this is about the LTE aspects. And coming to the nature of work and what skills are actually required for a developer or a tester. Okay, so I'll just mention about the developer because today's discussion is development. So these are all the things that you will be doing, okay, when it comes to the customer environment or when it comes to the development aspects, what kind of predominantly working the nature of work as a developer. Feature development and log analysis, issue fixing, porting to the other platforms. It means like for the other hardwares that we wanted to port to the same functionality. And enhancements, new enhancement. What are the skills required? Basically, these things that we are going to see now. Linux system programming and data structures, and these are all the things that we will cover. But C++ also a little bit I am actually covering. Okay, so coming to the 5G aspects. So with this background, means here actually 2 to 3 courses are there actually. So when it comes to when it comes to directly understanding about 5G, without this knowledge it is not possible to go through directly jumping into the 5G. But if you are opting for both, 4G and 5G, first of all LTE should be in place, otherwise it is very difficult for the 5G to understand. So who are actually opting for the for both 4G and 5G, so you can expect one of the thing little less, because it's a mix of discussion. Again, it will take very long time. So basically for the freshers I'll spend quite amount of time actually, around close to 1 year, 6 months to 1 year, for understanding everything in and out, in fact, actually, because it is a combination of domain and implementation and also the language coding skills. So high coding skills are necessary to understand the framework or whatever it may be to draw and implement the technology. So coming to the 5G aspects, we have use cases, business use cases and architecture, ENDC call flow, release 15 aspects that we will discuss. So once we have something called as deployment options, and there is something completely different when it comes to the core network and the entire end-to-end 5G network. Okay, so those things that we will cover as a part of 5G. So you can decide and let me know what you are actually opting for, that accordingly we'll take it forward. So physical layer design, so there is a new concept which is called as bandwidth part and SSB and the core set, means the way how it actually allocates, what happened with the 4G, where it is not fitting, and what kind of issues that we are actually facing with the 4G with respect to the bandwidth or with respect to the flexibility of addressing the new use cases or new applications where 4G is not able to address that. So that is one of the core reasons why 5G has came into place. But what kind of flexibility, what kind of new frame structure that came, okay, and it can able to address the multiple use cases with completely different set of requirements that 5G can able to address. Okay, so that's the reason why all these things are there, like for example bandwidth part, core set, right? So these things and all there, and RRC layer design. So the moment we talk about physical layer RRC, again it seems to be completely almost same with when compared to the LTE, but in order to satisfy this, accordingly we have majority of the configurations that will be included as a part of RRC. But when it comes to the base station, here it is completely different, because the base station generally we think it is an baseband unit, which is a combination of like RRU and the baseband unit connected by the CPRI cable, like that. So that is one aspect. But when until now we have seen in the 4G, but when it comes to the 5G, the division of the baseband is the baseband is actually divided into two parts. One is like CU and another is DU. CU means control unit, which will completely loaded in the cloud actually, and that can control multiple DUs. Means there is something called as real-time and non-real-time processing. When it comes to the real-time processing, it should be very, very close to the hardware and the antenna. And when it comes to the non-real-time processing, it can be in the cloud also, because you are not in a real-time need to process that. But still latency aspect has to be considered from the control plane or the user plane aspects. But the real-time processing, whichever you treat it as a real-time, okay, that should be placed in the DU. DU means distributed unit. One distributed unit can control one coverage. It means connected through the CPRI cable to the one antenna through the RRH, right? So those things that makes actually the difference when it comes to the architecture and when we are comparing with the 4G aspects. So that kind of things, and accordingly we have the combination of LTE and 5G aspects also that we can think of. So accordingly we have different things, DU handover cases also we have different things, and there are some changes, but this seems to be at least some 50% I can say, something similar. With the 4G background is in place, these things are little easier to understand. That is what I wanted to say. But still some of the things that you can see, RLC layer and polling and TM, UM, AM and PDUs, SDUs, the terminologies are exactly same, but the functionalities and what kind of changes to address the either the all the KPIs, in fact in general I'm talking about, the key performance indicators. I think we know that part, the reliability and the latency and the throughput and all the things, coverage, mobility, all the aspects that you can think of. And coming to the PDCP layer, again the same thing, but the new layer, there is one new layer because of something called as network slicing. We will cover as a part of 5G curriculum. So because of the network slicing, and when it comes to the SDAP, this is only user plane, and only when you are actually connecting to the 5G core. It's not based, it's not EPC core. So in that situation, the SDAP layer is used for addressing the quality of service flow. So that is about the domain aspects. And finally I'll just come to the coding part, what is actually needed for implementation. So sufficiently it will take minimum 4.5 months to 5 months to decently apply the domain knowledge and also the coding knowledge in order to gain fully, in order to take the best advantage of the coding system and also the implementation towards the layer specific implementation also. So coming to the coding aspects, what are actually the development tools that you will come across when we are implementing, and what kind of things that you need to understand and practice before going to set up any 4G or the 5G network. So practical C, advanced data structures and multi-threading in Linux. So we have 3 parts actually, you can see here. Another part 1 is talks about the basic C, but this is not a curriculum based or some university based C, because this is completely practical. We have to dig deeper inside in the RAM, what is actually happening in a computer system, and multiple Linux platform. This is purely the Linux platform that you can understand. How the C language is actually producing the programs, what are all the rules, what are the instructions that we need to give to the something called as compiler, so that we can write the best programs. But coming to the contents, what I'm actually covering, C operators like multiple. So basically when we are talking about the program, it is a combination of 2 things. One is data and another is operation. What kind of operation you can do. This is a very fundamental, but it can expand or evolve towards the algorithms and the functions and the implementations also. So that is going forward, you will understand time to time. And coming to the flow control, means we can take the decision. We should be able to take the decisions whenever we want. So for that reason, C language is providing this one. And something called as pointers. This is a very well-known topic, and where we generally think about many aspects and we'll face so many issues. We'll try to address those spots also. But when it comes to the pointers, we have so much of flexibility in accessing the different kinds of data. Like for example, we can access arrays. So these are all like course curriculum that you can think of, like arrays and strings and data structures, multiple things are there. So I'll be covering as a part of this, but this is purely just C language. And the data structures, coming to the data structures, we have structures and data structures. Both are actually different, because this is the different way of handling the data, and this is just a kind of a records that you can think of as a part of database. Just an example and visualization that you can think of. But when it comes to the data structures, we have stacks, queues, linked list, singly linked list, doubly linked list, and trees. But from the implementation perspective, okay, we no need to go beyond trees, or in fact beyond linked list also, but still we can cover these spots as well. Different trees and different operations on linked list, these are all definitely necessary. For example, I'll just give a real-time example in the context of base station and UV communication. Let's say one eNode B is there, and it has to process some 10 UVs in one particular coverage in one particular millisecond, one subframe, and the scheduling is in one subframe. Now you have to process as a base station in this coverage. So you will maintain the 10 contexts about the UVs. Context in the sense that particular situation, 10 UVs, 10 different ways, 10 different requirements, how you will maintain, and time to time if UV is going out of the coverage, how you will manage that resources, right? Either it is power or processor or memory or RAM usages, right? How you will actually maintain and manage to do an efficient processing, and how you can utilize the existing processors like i3, i5, i7, just an example to say. Okay, so how we can effectively utilize the cores what are actually present in the system, the hardware system. So that is about the things, but there are algorithms and complexity, these things are also there. Now coming to the Linux aspects. So Linux basically, this is where actually I was talking about the interaction between one layer to another layer. Let's say for example Mac has to communicate to the RLC, or Mac has to communicate to the physical layer. How it can communicate, what kind of mechanism, what kind of techniques. And we were talking talking previously about the channels, right? So the channels, you can think of this message queue, the implementation of the channel, let's say CCCH queue or DCCH queue or something DTCH shared memory, like that we can implement. Okay, but there are multiple things actually, interfaces and events and messages and event handlers, event triggering and port where we have to keep, right? All those things will come into the picture when we are actually implementing. And network programming, so this is not much necessary actually, but when we are actually making an IP communication, this is very much necessary. IP communication means one system to another system, how the communication will happen through the protocols. But here we are actually learning the network protocols, not the wireless protocols. But this is a fundamental thing to understand for any kind of protocols that we can implement. That is the main thing. And process, okay, this is for building the project, but we don't need to worry too much about this part when it comes to the make files. And multi-threading. So threads, basically it is a hot topic, and also we can effectively utilize the multiple cores with the help of multi-threading concept, where the Linux operating system will provide, by the way, the entire complete protocol stack understanding is with respect to the, in the Linux environment with the help of C or C++ coding. And so multi-threading is there for effectively utilizing the number of cores present in the one CPU. But it has its own issues. Okay, we have race conditions and locking mechanisms, deadlocks, and many other things actually that we will encounter, and we'll try to address those situations also. So this is a kind of a, this is the overall implementation or a development specific aspects that you can think of before starting the implementation. So that is the main intent, but I'll just try to show you, just I won't take much time, hardly 2 minutes. This is a kind of a code that you can encounter after understanding the coding, and also from the domain aspects. So I don't have much things to give for the demo aspects, so I'm sorry about that. But if you can think about this part, let's say for example from the domain aspects, you can see here something called as utrust stack, right? RRC configuration. So what is RRC configuration? What is physical layer configuration? RRC configuration. I hope my screen is visible, right? Hello? Can anybody confirm my screen is visible? Okay. I hope my screen is visible. So coming to the physical layer configurations, RRC configurations, so it has 5G configurations also. You can see here. The moment we are talking about RRC cell configurations, we have physical layer configurations, tracking area code, ARFCN, absolute frequency, band, right? So all these things that we will understand. But what is this one? Right, from the C coding perspective. See, every answer and every solution is here only. But the point here is how the way we are actually thinking. We are actually sometimes we'll think in the domain aspects, sometimes we'll think from the coding aspects. So these should go hand in hand in parallel. Then we can understand easily about the code. Physical layer configuration. Okay. So PCI, center frequency, SSB, these are all domain specific. It means going through the compliance of the 3GPP. Subcarrier spacing. Right. Okay. So these things that you will be going through, okay, you will come across all these things as a part of course. Don't worry about it. Okay, I think with this I can conclude my talk. So I'll take some questions. If you have any questions, let me take some questions. Any questions you have? Anybody have any questions?
When are you planning to start that training? Like, what is the
See, I am
probable time?
starting March 1st. Actually, 3 people have already registered. Okay.
Okay.
They have taken actually last week that training.
Okay.
Yeah. See, I will tell you one thing. Um, because it will be little difficult actually for because everybody will be having their own requirement. But just wanted to understand your requirement uh, in short. Because some people will come from C and C++ background, and some people will come from only 4G background and they want only 5G, right? So this kind of different set of requirements will be there. So it will be difficult to cover in a minimum of 3 months or 4 month short period. So depending on that, you can choose and opt and come to those sessions. I will be informing those sessions. That is the only way possible.
Okay, you start with 4G and 5G, right? Like
Of course.
the
See, I
domain
will go
and
in.
where.
I'll go in sequence. First, I will go 5G. Sorry. First, I will go 4G, and then 5G, and then C and C++ and Linux.
Yeah, and one more thing, that log analysis and all will be given, right?
Hmm.
Wireshark logs and analyzing those logs and debugging the logs.
Of course. Yes. Yes. No logs
And
you
what
will be
about?
able to generate actually.
Okay.
You can generate your RLC and MAC logs also.
Okay. And what about the like documents and presentation videos? Because see, you have explained so many things today,
Hmm.
so we'll not be remembering if I try to read it again, or if I go through like in future time, like that time we may need the like presentations or videos, right? What about that?
Okay, I'll do one thing. Okay, I'll
Okay.
share this recording.
Okay.
Okay, uh,
Okay.
that's why actually fortunately I have done the recording for this. Okay,
Okay.
I'll share this recording. Okay, you can go through the recording. Okay, but we will you'll come to know many details actually in the as a part of course journey.
Yeah.
Um, when it comes to the recording, I will be 99%. I will be going live only.
Yeah, but in future, if you want to like go through these presentations, then
Correct. Okay.
can we have this? Like, I'm sure, like we are not going to update in YouTube and all, but for our reference, because like in future, if you want, we can just refer these videos. That's what I'm thinking. Like,
Yeah. Yeah. Sure. 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 See, my only thing is like it should be kept confidential. That is the main
Yeah,
intent.
yeah, I am 100% sure.
Because
Like
you
we'll
know the
not discuss.
complexity, right?
Yeah, that is what. See,
And one
because
more thing is it is very difficult for to understand these technologies.
yeah, that is what I told you, right? I've taken some 2 3 courses in Udemy, and I've gone through a lot of YouTube videos and all, but I was not like satisfied with the technology, whatever they have mentioned. That is why I opted for this. Then I think I'm okay for this.
Okay, fine, no issue.
Hi, my question is regarding that log analysis part only. Like, uh, do we like have any specific tool? Like as you said, you can generate the logs for those layers and analyze. So like you will be giving any specific tools for training for this?
No, you are looking for testing or development because this
Testing,
is
testing,
test. This
testing.
is this is development discussion.
Okay, like for just testing point of view, I want to know like in
Okay,
case.
okay. See, when it comes to testing, first of all, tools are licensed tools. Okay, number one, and number two is like the same kind of information I am providing in logs also. Means which is 3GPP compliant.
Okay, so like if I have
And
to understand the flow regarding,
of
like
course, you can
as
able
you
to
can.
understand the flows with the help of Wireshark also, with the help of logs also.
Okay, so like for like Wireshark, like the basically which I have used Wireshark for just for air interface. Yes, I'm just my purpose is to gain to more on the UE side and between the layers how the communication and the how the flow happens.
Okay,
So
okay.
just my intention is go into that. So that's why I have attended this demo session. So just I want to know like whether the logs which you are
No,
going to
logs I
provide is
can
that like.
I can explain actually. Okay,
Mhm.
I have some tools actually. Okay, which are actually preloaded logs. Okay, which we cannot able to take the. I mean, I can give the visualization of the tools also. Exactly how to analyze, what to analyze, what kind of logs will be there, how the air interface logs looks like. But with respect to that, how the RLC and PDCP, those logs that we can able to see and analyze properly. Okay, I have a tool. QXDM I have, but QXDM is a little a demo kind of version. But still, we can able to take the live logs also with the tool. But proper decoders, those things are not there actually.
Okay, okay,
Yeah,
no problem.
but with
Thanks.
there is one MediaTek tool is there. Okay, so those
Hmm.
things that I can show the logs.
Okay, the GLT tools, right? The
Not
MediaTek
ELT actually. ELT is 4G
GLT,
tool
right?
actually. Okay,
Okay,
I have
okay,
3G tool,
okay,
but you can able to analyze very detailed way actually.
okay, okay. Thanks so
Yeah,
much.
yeah. Okay. So any other questions?
What is the time like? What time you're planning to take the sessions?
That I will announce actually, but I am planning from March 1st.
No, no, time. Like
Time mostly in the evening. I am planning in the evening only.
but you told in the morning, right? Morning.
Yeah, according to my availability, I have to plan actually. I am not confirming now. Okay.
Evening in the time, like what time?
Evening means
Because
7
we'll
to
go.
8:30.
Okay.
Too late is not possible for me, but 7 to 8:30 definitely I can make it.
Okay.
This time, like just now, how you have attended, right? So the same timing. Is it okay?
Morning is fine, but anyway, it's okay.
Yeah. Anyway, I think I will inform you. Okay,
Yeah.
related to that. Most probably, I will try. But majority of the people who are actually opting accordingly, I can decide.
Yeah, it's okay, not
That
an
is
issue.
better, I think. Yes.
Yeah, yeah.
Okay. Okay, fine.
Yeah,
Yeah.
yeah. Hi, Ramsa. Myself, Malakondaya.
Ah, yes, Malkonda. Yeah.
Yeah.
Thank you. Thanks for
So,
opting the course.
yeah, thank you.
Okay.
So, my intention is I want to complete early. So that's why I want to take the pre-recording videos. Is possible to take like that?
No, that I can see recordings from your side is not possible. Okay, but I can take the recordings and I can share. Not an issue.
Okay. So actually, I want to complete early. That's
No,
why.
see, the point here is this is a misuse recording. This is an open fact and it has happened so many times.
Yeah, yeah.
So I don't want to give such kind of things,
At least day by day
implications.
is possible.
Pardon?
Like each day, two videos is possible to complete like that.
Each day? Can we
Like
discuss this offline?
yeah, okay.
Okay. See, idea here is very simple. Actually, so many people are misusing this. That is the only reason. It is on request. See, point here is like because I anyway I can get the recording. Why should I attend the training? This kind of impression you will get, and you will lose the interest also going forward. That is the main reason. Okay, that is the main reason I request you to attend 99% live sessions. That will be interesting and interactive, and also it will be like for practice purpose also you will have your own self dedication. That's what my intent. Yeah. uh, Lokendra, okay. Hi Lokendra, how are you? Hello. Okay. Yeah. Any other questions? Okay, I think we will take it offline if you have any questions, Lokendra. Any other questions?
No.
Okay. So, how is the session today? I mean, like in terms of understanding.
Yeah, it was good, but I thought it was too much because as we are new to this 4G and 5G,
Yeah, understood.
like
Hmm.
and somewhere I also thought as per my opinion, uh, too much deeper things may not be required in future, because it may not at once if we get too much of information we don't remember anything. So for me, what I am looking for is the layman perspective, like okay, how the air interface is going, okay, what is the frequency bands, what exactly those frequency bands, and how we are sending the message or signal from antenna to the other node B. Those things I am like just curious. Like if you cover in that layman perspective, then it will be good as well.
Hmm. Yes, yes, we will cover that part. No, here,
And overall, it was good.
yeah, yeah, go ahead, go ahead.
And it was good actually, but I was not able to understand many of the things because as we started with these things, so I was knowing only the layered architectures and some of the functions of each layers.
Okay. So I would say one thing actually.
Yeah.
Um, in one instance, it will be very difficult to understand. And
Yeah.
today is actually about basic demo session I wanted to cover, but knowingly, unknowingly, I covered little bit more. So that's why sometimes it is too much like that.
Yeah, maybe.
Yeah. So slowly, time to time and day to day, that layers will be cleared off.
Okay. And in the meetings, we can discuss like the development perspective as well. I think, right? Like how
Of course,
we
this is
can,
only about development.
yeah, how for example, if data is coming from RLC to Mac, so maybe we need to have some kind of threads or process where it will process it. Some basic knowledge, like not in-depth information.
Of course, definitely, definitely.
Yeah, yeah.
No, when it see development wise also we can discuss, and also when we are going through the see the main thing what I am actually covering when we are talking about development, in the sense I'm talking about coding aspects. Okay, if it
Okay.
is a coding aspects, we are actually discussing about how RLC will interact with Mac in this particular situation. Let us understand one thread
Yeah. Okay.
like that, means the deep understanding will go in this angle,
Okay. Okay.
and the
Got it.
design and development aspects also, that we will discuss that part. So
Yeah. Yeah.
then
Sure.
it will be clear, right, how the
Yeah.
messages, how the interfaces, structures,
Yeah.
events,
Yeah.
event IDs, triggers, message handlers, everything.
Yeah.
Okay.
Okay, Ram.
Okay,
Then I
fine.
think,
Yeah.
yeah, you just let me know the date and times, and
The
we
date
can.
is March 1st, that is for sure.
March
But
first is
I'll
then.
take the feedback, and also I'll expect some guys to um, have that part, because one person or two-person will be little difficult actually, because the curriculum is little big. Um, around some, it's close to around some 4 to 5 months it will take, including
So
project.
anybody already registered or how it is like?
Two people have registered actually.
Okay.
Okay, fine. I think let's conclude for today.
Like if I join, it will be like you're going to take it, right? Because we are will become three then, right?
Yes, yes, yes.
Okay.
But
Okay then.
as you said, right, you wanted to opt for because you already know the coding part, right? As you said,
Yeah.
so you can skip the coding sessions, and fee will be reduced accordingly. Okay,
Yeah. Sure.
that's not an issue.
Mm.
But
Mm.
I suggest to concentrate on both 4G and 5G,
Yeah. Sure.
and directly jumping into the project. That is the
Mm.
main I mean main point I wanted to suggest you.
No, okay. First, you will start with 4G and 5G only, right? Not
Yes,
coding.
yes,
Coding
yes.
will.
Of course,
Yeah. Then.
definitely, definitely. Only 4G. First, we'll start with 4G, next with 5G, and then C and
No.
C++ and Linux, and then project. So C and C++ and Linux, you don't need to attend. Okay. Then
What is the project? What will be there in the project?
project means first you will have one setup, and from that the execution and log analysis. From that you will do the reverse engineering, and then you will try to understand the framework. Then you will go back to the specification requirements and code mapping.
Okay. And in this 5G and 4G training also, like we will be analyzing the logs and debugging the logs, right?
Of course, definitely.
Yeah, because see, I have already in 5G project, and if it takes another 6 months to analyze the logs and all, I think it won't be helpful. So if we start in the like whenever we start 4G and 5G domain knowledge, that time itself, if we are analyzing the logs and like if I get that information in the early
No,
2 3 months, then
it will be all a mixed discussion, right? Because some people don't know about coding only.
okay, okay,
You understood, right? But as a part
yeah,
of this 4G and 5G discussion, as a part of 4G and 5G discussion, okay, we will go through Wireshark logs and some parts
okay,
of let's say 3G logs. Okay,
okay,
okay. Either 3G or 4G or 5G. The point is how to analyze, and because people are always fond of these tools, that is the main
hmm,
intent. They never care
hmm,
about whether it is 3GPP compliant or not. But
okay,
that
okay,
same kind of things that we are actually getting in Linux environment also. But unfortunate thing is they are always believing the tools.
okay.
That is one thing. But still, whatever we are working on the Linux environment, those are 3GPP complaint only. Those are exactly the same messages only. But unfortunately, they won't believe, testers especially.
Hmm.
That is the main thing. Okay.
Okay, okay, Ram. Then you
Okay,
just let
fine.
me know.
Not an issue. Okay. Fine, fine. I'll
Yeah,
let you know. Okay.
yeah.
Okay,
So,
fine, fine. Yeah.
bye.
Yeah. Okay, Lokendra, are you there? I think you have left. Maybe. Okay, fine. I think let's conclude for today. Hello.